The final step in solving our business dilemma is to add in an attribute of every tank that will tell us the mass share. In other words, the mass of this tank as a ratio of the total tank farm mass. So in the library, for my tank template, I can add in a new attribute that will hold the mass share. Now mass share, of course, will be a percentage, and I can do that with a formula, kind of as we've done before, right? If I'm dividing one thing by the other, that seems pretty inexpensive, so I'll do that on demand. But in my formula, I do the easy part. I pull in the M for mass of the tank in tons. And then I want to pull in the mass of the tank farm. Oh, interesting. I don't see that as one of the things I can pull in. The closest thing I see is other, which frees up a nice little syntax cheat sheet here of relative references that we can make. For example, if I know that every tank is going to be the child of a tank farm, or something that has a mass, I can just say, alright, this total mass is going to come from your parent. Just look above you, that's your parent, grab their mass attribute, whoever they are. So we have a syntax that can do that, and if you're familiar with the command shell, where if you're navigating a command shell, if you want to go up one directory, you've got 2 dots. If you want to begin a path at the current directory, you've got 1 dot. If you want to go back to the derived root, you can put in a backslash. You get the idea. We use a very similar syntax here in PyAF. So if I want to go up 1 level to my parent, and then I want to get the value of his mass attribute, I'll go up this 1 level, and then looks like specifically for attributes, I use a bar and then the attribute name. So I'll say mass. Go up 1 level, grab your parent's mass, and just use that. And that we want to see in tons as well. Okay. So now that makes my equation something along the lines of mass divided by total mass. But to avoid, divide by zero errors, anything like that, the formula data reference does have some functions and operators that we can use. So if the total mass is greater than 0, then give me a ratio otherwise there is no mass in any of the tanks. This result is in percent. Let's see if this works. Sure enough, 5 tons is about 1/3 of the overall tank farm mass. So each of my tanks is calculating its mass and its overall mass share. And this was done using that relative syntax in the formula data reference. So there you have it. We've got mass share exposed for every tank. That's exactly what management wanted to see. We've put it in infrastructure where any PyAF client, like ProcessBook or DataLink, can see it. In addition, we can even include this in reporting for dashboards, etc., using PyOliDB Enterprise. It's there, it's available, all of that time series data exactly as we wanted. So now the final step is to really check in all of our changes. If you've used a content management or version control system before, you've seen this whole check-in, check-out mechanism, where if you edit an object in PyAsset Framework, it's checked out to you. And we, when we're done with it, can apply our changes to the world and release our lock on that object by checking in the changes. So we'll check in these changes, and now the objects are unlocked and other people can see all of the great things that we just did. If we want to edit them again, we will need to check them out. Now in System Explorer, this checkout thing happens automatically, where if we try to edit an object, it gets checked out for us. In code, we'll need to do this ourselves, but it's exactly the same mechanism. Check out, and then when we're done, be able to check that in specifically, or apply check-ins across the board.